So in conclusion, old diseases can become a new threat to or a disease in an animal which has never been seen before. Bovine tuberculosis holds a true threat to lions and other species. There is also a huge lack of good scientific data to help in improving and understanding the control of BTB, especially in free-ranging wildlife, especially lions. One needs to act sooner rather than later as to prevent a collapse and possible increased danger of extinction for the lions that is due to the disease and not just an anthropogenic factors. The loss of lions will have a huge impact on biodiversity and lead to a change in the ecosystem dynamics as being an apex predator. New maintenance hosts can develop and make the disease of bovine tuberculosis even more complex than it already is, and even more difficult to remove and maintain. Eradication is very unlikely in a free-ranging scenario in lions, but may be controlled outside in smaller controlled environments such as captivity and smaller parks, in which the genetics can either be replaced or prevention methods can be put in place. These are the references that I've used. I thank you very much, everybody and colleagues, for listening. If there's any questions, please feel free to email me. Thank you. Good day, colleagues and Dr. Earp. I will now be talking to you about avian influenza and how anseriformes, a family of ducks, geese, and swan, play a role in the dispersal and emergence of the disease in humans. Now, anseriform ducks, geese, and swans and others such as terrariforms, family shorebirds, are the ones that mainly are the maintenance hosts for avian influenza. Now, epidemiology is best understood in the anseriform family of birds. Now, let's discuss some of the history of avian influenza. Now, avian influenza is an orthomyxovirus with an RNA single-strand negative sense. Now, the common name is bird flu and has been recognized as a poultry disease over the past few centuries, as far back as 1878 in Italy and Europe, and it has a global distribution due to the fact that birds such as anseriformes can spread it. Now, in 2006, a highly pathogenic virus, H5N1, originated from wild avian species that emerged in Eastern Asia, affecting both poultry and various mammals and humans. Now, most of the AI viruses do not need to infect humans. However, some, such as the H5N1 and H7N9, can cause serious infection in people. It has, however, been demonstrated that only a few representatives of H5 and H7 subtypes, in fact, can display highly pathogenic biotypes. Now, avian influenza has a morbidity and mortality rate as high as almost 60%. This is according to the World Health Organization. Now, the greatest economic impact of avian influenza falls on the poultry industry, and the risk is carried to humans is when the highly pathogenic avian influenza subtype mutation gene happens, and at this point, luckily, there is no human-to-human transmission at this point. Most avian influenza strains, as mentioned, do not infect humans, but the pandemic ones are well known. Now, avian influenza is a controlled disease here in South Africa, according to the Disease Act that is written here at the bottom. Now, the history of avian influenza is there's basically two types. A low pathogenic avian influenza, which very rarely causes deaths. It can be any of the subtypes and is usually bound to the gastrointestinal system. On the other hand, you have the highly pathogenic avian influenza, which is has a high mortality rate, is usually H5 and H7 subtypes, and replicates in any body system. Now, you'll see there are a few birds that have mentioned on both sides that can travel across the African side, as well as are some pelagic birds, which is also migratory in nature. Now, all 16 subtypes of avian influenza strains are carried by aquatic migratory birds. Now, the subtypes of avian influenza that is of main concerning types are, as I've mentioned, is the H5 and H7, which is highly unstable genetical makeup that leads to its high antigenetic shifts in the genes that can make it easier to be transmitted to different species. Let's take, for instance, one of the recent ones, the H5N1 in pigs. Now, usually H5 and H7 viruses are stable and maintained in the natural host in a low pathogenic form. But transmission of all avian influenza viruses in wild bird populations is dependent on the fecal and oral route. Now, in ducks, it can replication occurs primarily in the intestinal tract, and high concentrations of the infection of the virus is usually shed over certain times. Now, in my opinion, listen to the words tick tock, boom. It is a situation that is waiting to happen, especially with the high genetic mutation aspects. Now, the history of avian influenza in ducks is common. Like I said, I'm focusing on the anseriformes, which are ducks, geese, and swans. Now, in 1961, before the recognition of H5N1 in the Asia situation, there was a die-off of common terns of H5N3, which had massive mortalities, but it did not persist in the species for very long. Now, this was the representation of the only highly pathogenic avian influenza virus which was ever isolated from free living birds. Now, CIRAD, which is a French agricultural research and international cooperation organization that studied together with South African and biological researchers, indicated that the avian influenza virus is sustained all year round in Africa, and especially in certain hotspots. Now, the African shell ducks and dabbling ducks seems to play a crucial role in the persistence of these viruses in the African ecosystem, and it is similar to the role played in temperate ecosystem. Now, migratory ducks have the capacity to disperse the virus over long distances, but the probability of such dissemination for a given bird is very low. It's approximately 5 to 15 days per year, as each bird only rarely travels such long distances in one go. Now, the history of avian influenza in South Africa is that there has been several occasional outbreaks of highly pathogenic avian influenza. The first time was in 1963, when there was 1,300 terns that died off in the Western Cape, and that was by H5N3 HPAI. The second was 40 years later in 2004, when 26,000 ostriches needed to be culled in the Eastern Cape of the H5N2. But it was only picked up when there was a mortality shift from 5% to 44%. And then at the same time, in 2004, they picked it up in an Egyptian goose in the Western Cape. Now, the third outbreak was a re-emergence in the ostriches in the Western Cape of the H5N2 type. The fourth time it broke out was in 2011 to 2013, and the ostriches were only quarantined, and it was identified to be an H7N1. The fifth time it broke out was just 2 years back, also in ostriches, which led again to the culling of, and again it was H5N2, but this one was totally unrelated to the ones that were broke out in 2004. Now, this suggests that virus originated from the wild birds in the Western Cape and may have mutated into a highly virulent form in the ostriches in the Eastern Cape, and also some ostriches of the Western Cape. Now, ostrich farms in South Africa was particularly hard hit with these situations, and again, it can be hard hit in future as well. Now, usually H5 and H7 viruses are stable and maintaining their natural host in a low pathogenic form, as mentioned, but avian influenza main vectors of transmission occurs via the continents where migratory aquatic avian fauna is found. Now, avian influenza detection rate usually exceeds about 30% in hatching birds prior to the migration. Now, the exposure and introduction to poultry and ostriches and stock and other livestock can occur usually via various pathways, but mainly via the drinking water, direct contact, and exposure. But at the same time, these exposures in 2014 led to a human case, which was occupational in nature, and it was done that it was serologically positive case of in South Africa of H5 and H7 by our National Institute of Communicable Diseases. Now, according to the World Health Organization, there are 3 requirements to start a human pandemic. A viral strain, which there is little or no immunity in humans, must emerge. It has to be able to cause serious illness in the humans, and it has to be easily spread from human to human. Now, only 2 other of those 3 have been seen in South Africa, and there's been no human or animal cases of H5N1, according to the World Health Organization. But there are an increased amount of species involved, and it can lead to different scenarios which humans can be infected. such as the picture on the right hand is showing, that there's a generation of pandemics in avian influenza strains which passed through a passage in the pigs, which then led to the human cases, which then could have spread. Now, in South Africa, this, or shall I rather say, should it reach Africa, these avian influenza strains, it can only lead to a catastrophe. Illness in humans across the world has only been seen in H5N1 mostly, then H7N3, H7N7, and H9N2. But the northern countries of Africa has been hit, such as Nigeria and Las Peoples Democratic Republic of the Congo in 1996. Now, in connection with the epidemiology in South Africa is at the end of the migratory route of most aquatic birds. There are several factors that may attribute to the fact that these outbreaks are rare in Africa. Now, I'll discuss the migratory surveillance a little bit later on during the presentation, but first of all, there is no large-scale duck or turkey farms in South Africa or Africa. And although ostriches may periodically be infected, they are atypical terrestrial hosts for avian influenza. Now, ostrich farms and the main poultry producing areas are many of the times geologically separated from the areas in which these migratory birds are. And then, of course, we're a semi-arid environment all year round. So water sources are usually bound together, and this causes rounding of water birds that congregate around large bodies of water. Lastly, one of the reasons that it's rare is South Africa, we usually do not regularly trade or eat ducks or aquatic or water type of birds. Now, with the surveillance, South African avifauna, through a dedicated surveillance program launched in the wild avian migratory species in 2004, it was determined that key characteristics of South African or shall I rather say southern migratory avifauna did not follow the migratory paths and did not take actual predictable migrations. Thus, South Africa's migratory avifauna behave in a different manner to other migratory birds to the rest of the world, such as in the United States, Europe, and Russia and those places. The study revealed also that wild aquatic birds could carry both highly pathogenic avian influenza and low pathogenic avian influenza into South Africa, and that a controlled surveillance program could help in prevent and control the possible future outbreaks. Now, the methods of surveillance usually produced in doing this study was passive and active. Now, passive is an opportunistic, where the fresh dead birds or avifauna is usually taken, and then they do a post-mortem, and it continues in it's an ongoing situation at this point in the National Zoological Gardens, which is situated in Pretoria. Now, active surveillance usually is the capture of the aquatic birds, such as target selection and testing of certain birds. And usually it's by capture and sampling methods that are drawn, and then environmental fecal sample collection and blood samples are also taken. Now, all these samples of both of these are sent off to OVI, which is accredited World Health Organization facility for testing for avian influenza. Now, the spatial actual surveillance study that was discussed early on, South Africa, there are certain areas that are most at risk. Remember I spoke about the hotspots in the water where they accumulate. Now, this was in a study done by Cunning et al. In 2008, where most of the aquatic systems are close to Cape Town, Joburg, and KwaZulu-Natal, especially the Eastern Cape, which was now previously seen, like you guys seen, with the ostriches outbreaks was quite a lot of them. Thus, the surveillance risk mapping that was done by Cummings indicated areas of possible origin of avian influenza outbreaks and helped in establishing a risk map for areas and enhanced surveillance of avian influenza in Africa. Now, the collaborative research that was done in Cummings was done by the Department of Environmental Affairs, CIRAD, which is the French organization, and South African National Institute for Communicable Diseases, as well as GANGE, which is a global avian influenza network for surveillance. Now, they used PCR and real-time PCR methods to identify different strains involved in these outbreaks. This helped to decide the control methods, such as previously culling or non-culling, just quarantine, that was seen in 2011 and 2013 versus 2014's outbreak in the ostriches. Now, if you have a look at the figures below, the one on the left is the areas the most are at risk in southern Africa, including some parts of Botswana, Namibia, Zimbabwe, But you can see that the red areas is especially those that are high